The following KOPN podcast is made possible by the generous donations from listeners like you. Please consider a donation to listener-supported community radio, KOPN. You can donate securely online at kopn.org. Thank you. Hi, welcome to Food Sleuth Radio, where we help you think beyond your plate. I'm Melinda Hemmelgarn, a registered dietitian and investigative nutritionist on a mission to connect the dots between food, health, and agriculture and find food truth. And today I'm delighted to welcome my guest, Ms. Sydney Evans. She is a science analyst for the Environmental Working Group, which is a nonpartisan, nonprofit organization based in Washington, D.C., and dedicated to helping us live our healthiest lives. Ms. Evans has a specialty in water, pesticides, PFAS chemicals, and that is what we are going to be diving into today, specifically PFAS. We see the headlines. We want to know what they are. Ms. Evans focuses primarily on tap water contaminants, exposure analysis, and children's health. And before joining the Environmental Working Group research team, Ms. Evans worked as an environmental health specialist at a local health department in Indiana. She has also served as a guest lecturer for Indiana University's environmental health classes. She holds a BA in chemistry from the University of Virginia and an MPH/environmental health degree from Indiana University in Bloomington. Welcome, Sydney.
Thank you so much for having me.
I am delighted. I think so often as a dietitian, I remember learning that water was our most important nutrient. And I don't know that most of us think about water like that, but indeed it is. And I think too that we turn on our tap and we think, oh, the water coming out is totally fine. It's tested. It's safe. And yet what we're learning is that there are these forever chemicals in our environment and in our bodies that can pose health threats. And of course, if it's in the water, it's also in fish. So we're going to dive into these issues today. But first, I want to know, what was it exactly that got you interested in environmental health specifically?
Wow, it was definitely a process. So I started out studying chemistry in college, and I started taking more classes in environmental science and wanted to do something with that. So really it was about figuring out how things worked and learning about these different pollutants, these chemicals. And the advocacy part of that got me much later. The more that you learn about these issues, the more you're like, wow, this is really wrong. This is bad. I need to do something about this. And so that's kind of gotten me where I'm at today.
Well, I was alarmed when I read that over 90% of U.S. citizens have PFAS in their systems. And of course, you've probably seen the cord analysis from mothers delivering babies, and they find many chemicals there. And it's alarming, isn't it? When you were doing work in Indiana at the health department and you were focused on children's health, what were the issues that you were looking at there?
I really enjoyed working at that level because it wasn't like I was diving into the heavy research and doing these sampling projects and things like that. I really was just trying to answer people's questions. I had to be a generalist and a jack of all trades because you never know what people were going to call in with next, saying, hey, I'm concerned about this. What do you know? What can I do? And so I think that was really my favorite part of it. So I worked on a little bit of everything. It wasn't until I started working at EWG that I really started specializing in tap water and water contaminants and later PFAS.
Yeah. Okay, so let's dive into tap water. If you had to look at a map of the United States, would you say that some regions have more issues than others? I mean, I'm assuming it's related to what kind of industry or production, agriculture, could be metal plating, could be Department of Defense, military sites. Do you think that the tap water in the United States is largely contaminated?
I think I could say with a pretty high degree of confidence that everybody in the U.S. has some sort of contaminant in their tap water. Like you said in the beginning, a lot of us I know I did. I took my tap water for granted growing up. I assumed it came out of the tap. It was treated, it was cleaned, it was great. But that's really just not the reality because there's such a big difference between what is legal and what is safe. And that's something that I really want to hammer home and make people understand that there is that gap. And that's an issue all across the United States, not just in some
Yeah, that is a really great point. So when we look at some of these toxic persistent chemicals, who decides what's legal and who decides what's safe?
So ultimately, those regulations, the limits for drinking water, are set by the EPA. But based on what we've seen from utility testing data that's featured in the EWG tap water database, that's utility testing, not our testing, there are hundreds of different contaminants. And these are just the ones that we're actively testing for, that the utilities are actually looking for in their water. Only about 90 of those are regulated. So we know that there are hundreds of contaminants in our water. Only some of them are regulated. And even the ones that are regulated, they're not necessarily limited to an amount that has no health concern. There's this trade-off when these regulations are set between what is healthy and safe and what, at least at the time, might have been cost-effective. Now, that's a whole other route we can go down about the cost considerations and how outdated some of these regulations are. But that's just for the ones that we know about. There are always emerging contaminants, and a few decades ago, PFAS was one of those. But I don't know if we can say it's emerging anymore, but it's still not regulated, and this is something we've known about for a long time.
Yeah, that's really frightening. So let's talk about PFAS. What is, when we say PFAS, what does that stand for? What are the class of chemicals considered under that umbrella term?
Sure. So it stands for per and polyfluoroalkyl substances. And I know PFAS is not probably a household word, but a lot of people are probably familiar with products that might contain Teflon or Scotchgard or nonstick chemicals generally. All of these kinds of coatings are made with PFAS compounds. It's a whole family of compounds. The original two, at least as we think of them as being original, were the ones that used to be made with Teflon, Scotchgard, that kind of thing. But there are hundreds of these in use now, and they all have similar health impacts, which I assume we'll get to in a moment. They were made decades ago, and they are used in all kinds of applications. That's industrial applications, firefighting foams, all of your stain repellent kind of gear. I mean, they're in everything. It's crazy.
I know, I was thinking about some of the things that I have in my own kitchen, and I'm pretty careful, not to use plastic. I don't use nonstick cookware, but I have rain gear to go out and hike in, and that's got repellents. I remember buying children's pajamas that were flame retardant. So it's really hard to avoid these chemicals when you go into a typical consumer marketplace. Do they have to be labeled?
They don't, not that I'm aware of, and not at any kind of federal level. That's one of the challenges with these is we're fighting so hard for some monitoring requirements in drinking water, but what about all of these other uses, right? Whether, it's migrating from food packaging even, and that's not anywhere that you can read on a tag. If you are going to try and avoid these things, there are some steps that you can take generally, and then there are some brands that are trying to remove PFAS from their products. But as a consumer, it's honestly really hard, which is why we need more action. It shouldn't be on us as individuals, it should be on us as a society, and this is why we need more regulation and legislation to protect us from these compounds.
Exactly. And we should touch on some of the health risks related to PFAS. So the ones that I have from the Environmental Working Group site are they increase the risk of cancer. They harm fetal development, resulting sometimes either in birth defects or in low birth weight. And then they also can reduce vaccine effectiveness. Are there any other specific health effects that you want to hone in on?
Those, I would say, are definitely the big ones. The cancer risk and the reduced vaccine effectiveness are the most concerning. There are a few others. It's been linked to increased total cholesterol, so if that's something you're concerned about, that's an issue. And then we've seen similar kinds of effects in animal studies as well. So general liver toxicity, immunotoxicity, developmental and reproductive toxicity. So these are not things that you want in your water or in your food. These aren't things that you want in your body because we see these effects at really, really, really low levels. This is not something where you need a large dose. It's really small amounts that can, over years or decades of exposure, start raising risks for these effects, which is really concerning.
I'm glad you brought that up because I did a little bit of research, again, on the EWG site, and I was specifically looking at some of the Department of Defense information because apparently a lot of the contamination, say for the Great Lakes region, is related to Department of Defense activities. And they have been aware of the toxicity related to PFAS, but they really haven't done much about it. So I saw that the European Food Safety Authority set a consumption threshold of 4.4 nanograms per gram per week. For a 160-pound person, a safe level of exposure to PFAS in food for an entire week would be 332 nanograms per gram. But 1 8-ounce serving of lake trout at 11 nanograms per gram would be more than 7 times this weekly limit, and 1 trout from Lake Erie with 136 nanograms per gram of PFAS would be almost 100 times more than this weekly limit.
Yeah.
It's shocking.
It's shocking. And you point out this is in order to kind of find references for these kind of safe limits. We have to look to the European Food Safety Association. Like, why don't we have our own limits? It's just really frustrating for somebody that has been working in this area for a while. You know, I haven't been doing it for that long, but EWG has been in this for years. And to know that there's still no regulations on this at a lot of levels, it's really frustrating.
You know, and it's interesting what I did after I read this about the Great Lakes. I went online and I looked to see what the different departments of health, what their recommendations are, because all across the country, if you want to eat fish from any body of water, you can go to the Department of Health for that particular state and you can find out what the limits are. And I'm especially concerned, you know, as you are working in the area of child health, who are the most vulnerable citizens? Those are the ones that have to be protected. So it would be children, it would be pregnant women, it would be women of childbearing years. And you start looking at the contaminants that are in the lakes, and I didn't find any mention of PFAS. I found mercury, I found dioxins, I did not find PFAS. So to your point earlier, there are many, many more toxins that are even being tested for.
Absolutely. This is something that we've been calling for a really long time. And a lot of people ask, well, how do I find out if it's in my water? How do I know if I'm exposed? And there are some resources and some testing, and we can go into that if you think that's warranted. But for a lot of people, there's going to be no information on whether there's PFAS in their drinking water system, in their environment around them, because in most places, it's not designated as a hazardous substance, which we hope to change. But because of that, there's no requirement for that kind of testing. There's no reporting. There's no cleanup standard on a national level. And that's why these things exist at really high levels, at dangerous levels, and yet people cannot even know about it.
Yeah, absolutely. Let me take one break to remind our listeners that if you're just joining us, you are tuned into Food Sleuth Radio, and we are speaking with Ms. Sydney Evans. She is a science analyst with the Environmental Working Group, and her area focuses primarily on tap water contaminants, exposure analysis, and children's health. And we are talking about PFAS chemicals. They're also known as these toxic, persistent chemicals. I want to touch on something that you just said about how long have we known about these chemicals. So the Department of Defense has long known about the toxic effects of PFAS pollution. In 1973, an Air Force report cited the toxic effects on fish and recommended the use of carbon filters for drinking water to prevent contamination. And then subsequent Air Force and Navy reports in 1974, 1976, 1978 also cited the toxic effects. But where are we? In 2000, the Department of Defense learned that 3M planned to stop making one of these particular compounds after internal studies showed evidence of health hazards. But if these are considered persistent, accumulating, and toxic, then even if we stop now, I'm assuming that the chemicals that were present in the water 30 years ago are still there.
Yeah, absolutely. That's one of the big reasons why we're so concerned about this is because, one, it's actively being pumped into the environment with no real limitations or regulations at the national level. And then on top of that, what's already in the environment, even if we were to stop all today, all manufacturing use of it, everything that's currently in the environment is basically going to sit there for forever. These things, they just don't break down, whether it's in the environment or in your body. And in all of that time, they can have that toxic effect and they end up spreading, right? So they never really go away. They don't really break down and degrade. They just stay in the environment, which is really, really concerning because this takes us into a slightly different direction. But what do we do when we start trying to clean up these compounds, when we finally get to that point, fingers crossed? What do we do with it? Because if we can maybe remove it from the environment, but where do we put it? And that's one of the issues. One of the big sources of PFAS, especially in the Great Lakes area, like we mentioned, is the use of firefighting foams at these military installations. That's a huge thing that needs to be dealt with. But there's also the industrial uses. There's all of the consumer goods and things where they go to the landfill or they get flushed down the drain and then it ends up in our waste stream. And then what happens? Our waste streams aren't designed to deal with PFAS. So it just ends up leaking back into the environment and cycling around. And that's how more and more people get exposed in areas that maybe aren't even near one of these contamination sites.
I had done an earlier interview on PFAS, and I was focused on the PFAS that you get from food packaging. So fast food wrappers, for example, pizza boxes, microwave popcorn. We were really focused on just looking at the direct food kind of consumption that we might have. But with this latest environmental working group report, it really makes us take a much bigger look in terms of our water, our larger environment, and how, as you mentioned, these compounds stay with us. I am assuming that PFAS probably stays in our body fat. Is that correct?
I would have to double check on where it accumulates. I think there have been some new studies that are being done, but it does persist in the human body. It takes a really long time. And it's actually interesting because we use animal studies a lot of times to kind of determine toxic effects, but it persists longer in people for some reason than some animals. And so we get this longer exposure for the same amount, right? If we continue being exposed to a source of PFAS, it's just going to continue to accumulate. And it takes a really, really long time for that PFAS to leave our bodies. And there's nothing that we can do to speed that up. It's just a matter of time. So that's why it's so important for us to limit our exposure where we can so that we have time for those levels to drop and our risk for health effects to decrease.
Yeah. When we do diet education around reducing toxins and reducing toxicity in our food, a lot of recommendations focus on eating lower fat animal products because if not PFAS, other chemicals tend to persist in the fat component of the food. So that's just one of many recommendations that we give. But another recommendation, and this was a recommendation from the President's Cancer Panel report, years ago, that said all Americans should be filtering their water. And I wanted to ask you about what kind of recommendations you give if we know that PFAS is in our water, as well as other contaminants. What is the best filter to remove it?
Sure. So PFAS can be filtered out with a home filter. That is definitely possible. Standard granular activated carbon filters can definitely reduce PFAS levels. It's better on some compounds than others, but it does work. And any kind of reduction in exposure is good. And then the reverse osmosis filters as well are going to be really great for removing PFAS. But I do want to take a step back and say, well, that is definitely an option. If people are looking for an immediate solution, something they can go out and do today, that is the way to go. That is something you can do to protect yourself. But like you just mentioned, everybody should be filtering their water. And I just think, why? Why is the burden on everybody in the United States who has treated tap water now under this pressure to filter and treat their own water? That just seems a little silly to me when we have these big treatment plants that should be able to serve their communities. And even beyond that, they're not responsible for contaminating the water. It's the things that are happening upstream. Why are we putting this burden on individuals to filter their water, and then allowing the companies that use these compounds to discharge directly upstream of our drinking water. That just feels a little silly to me. And then, of course, not everybody can go out and get a filter, and I recognize that.
Exactly. The idea that everyone needs to go out and spend money to get a water filter when not everyone can afford one, not everyone has access to one. I don't think that we should be externalizing those costs when, as you say, industrial use of these chemicals are putting them in farther upstream. That is such a public health tenet to get to the source of the problem rather than keep on throwing Band-Aids or filters farther downstream.
Right.
Well, tell me more about some of the work that you want us to know with regard to PFAS.
I think the biggest thing, I think this conversation started about, the Great Lakes report that we put out and how high some of those levels were detected in groundwater around the Great Lakes. And that is so important, especially for people in those areas, to be aware of these kinds of compounds. But we're really estimating, based on some of the sampling that we have done and reports that we've put out and the publicly available data, we really anticipate that everyone's water has some level of PFAS in it. Everyone. And that just goes to show how persistent these contaminants are, that it's in everyone's water. Now, not everyone's water has been tested. We think it should be. But that's what it looks like. I mean, we did a national PFAS assessment where actually me personally went to a bunch of cities across the U.S. and collected a tap water sample just to see if PFAS was there. And in, I think, all but one sample out of the 40 or so places we tested had PFAS. And then I tested taps here in Virginia, in my own backyard in the D.C. area, and all of them have PFAS. So just because the testing isn't there yet doesn't mean that you haven't been exposed. And so just making sure that people understand where our systems are failing us, because you would think that with all of the regulatory bodies that we have, not just for water, but for everything, that we can have some level of protection and surety that our food is just food, that our water is just water, and that it's safe to give to our kids. But there are gaps, and it is such a burden to try and educate yourself about these issues and to worry about it. But that doesn't mean that the risks and the issues aren't there. So just encouraging people to go and educate themselves. The EWG website is a great place to start. The work that we do, I think, is really high quality. And PFAS is not the only tap water contaminant. So just to go out there and question things and kind of figure out where those gaps are and where you might be exposed to some of these contaminants, because they're there. And hopefully that will encourage some people to take action and get involved and trying to call for change.
Right, exactly. So you mentioned the EPA and their role in testing for some of these compounds. What is the FDA's role?
That's a hard one. That's not something I'm as familiar with. As a tap water researcher, most of my involvement has been with the EPA. And while we do have a lot of really good food programs and reports on pesticides and foods, things like that, I'm personally not as familiar with the FDA.
Well, I had pulled up some information about it because of the PFAS reporting that I did earlier about the contamination in food. And what I found on the environmental working group, there was a press release about FDA test results again downplay the risks of these forever chemicals in food. And the FDA continues to ignore other routes of exposure to PFAS, such as drinking water, when advising consumers about the risks posed by the chemicals in their food. And when you think about it, so many of our foods, you add water to them when you make them. So it's all connected. And then there's the issue of these synergies. And it's true for pesticides, for example. Each pesticide is tested individually, but never in combination. And one has to wonder, so there's PFAS in the water in the Great Lakes, but then again, there's also dioxin. There's also PCBs. How do these chemicals interact? Is anybody looking at that?
It's something that is still being fleshed out, but the research community is definitely on it. And so, one of the studies that my team did is we just took all of the information about, say, drinking water carcinogens, all of the things that we know about regularly tested carcinogens in our drinking water. And we said, okay, what if we take these and we look at cancer risk, not just one chemical at a time based on the safe limit that way, but what if we look at these in combination? So we did that for, I think it was 50,000 systems across the United States, water treatment systems, and looked at all of these different compounds in real mixtures. These are mixtures at levels that people are drinking today, and looked to see what the cancer risk is. And it's far above what we call the de minimis, the minimal cancer risk to a person. So if you were exposed for a lifetime, we would expect no increased adverse health effects. And it's far above that when you start looking at all of these things combined, because most people have multiple contaminants in their water. It's not just one. And in that study, PFAS wasn't even considered because we don't have enough information. So there's this risk of what we do know, and there's risks of what we don't know. But I did want to go back to a second when you mentioned the FDA testing that was released. You know, in that they downplayed the risks. They said that there weren't many detections in a lot of popular food products. But when you start digging into that information, there are limitations to testing depending on which lab you use and which method you use. And so when you look, what was it? Around 4 nanograms per gram per week would be a safe level to ingest. And then what EWG supports as the safe level in drinking water is just 1 part per trillion. But when you start looking at the detection limits for some of these tests, they're really high, and they're much higher than where the health effects start. So they're like, yeah, sure, we didn't find anything, but that's because they're not looking for anything below, say, 30 parts per trillion or 20 parts per trillion, when we know that things much below that level are harmful to our health. And so saying that you have a non-detect, is what it would be called in some of these tests, is not the same as zero. And I do want to draw people's attention to that when you see reports like this, to know the difference between a non-detect and a true zero.
We're going to have to close because we're out of time. Very quickly, just yes or no, is bottled water necessarily safer?
We do not think that bottled water is necessarily safer. There's less transparency in testing, and there have even been cases where there have been public statements and warnings put out against certain bottled waters because the PFAS in them was so high. We just don't know, and that's the biggest question. So I would not use bottled water as a method of protecting myself over, say, something like a filter.
I will provide a link to the Environmental Working Group, which is www.ewg.org, and specifically the PFAS timeline. But unfortunately, we've got to close. I need to thank our listeners for joining us. Remind everyone that Food Sleuth Radio is produced by Dan Hemmelgarn for KOPN Studios in beautiful downtown Columbia, Missouri. Most of all, I want to thank my guest, Ms. Sydney Evans, Science Analyst for the Environmental Working Group. Sydney, thank you so much for being my guest today.
Thank you so much for having me and for your interest in this topic.